Okay, so first thing we're going to do is that we are going to see what happens if we have a real object, and we're going to put the object in a few different places on our plane, and we're going to see what happens to the image when we move our object around. So we're going to put our object beyond C. We're going to start out and we're going to put it beyond C, and then we're going to see what happens to our image. And then we're going to put our object on C and see what happens to our image. We're going to put our object between C and F and see what happens to our image. We're going to put our object on F to see what happens to our image. And then we're going to put our object in between this point right here, your F and your V. We're going to put our object here. So we're about to draw examples of five different scenarios of where our object is in relationship between our curvature and our foci. So we're going to do that right now. But first of all, let's go over what these variables mean and what they are. So the first C right here is your center of curvature, which is the center of sphere of which mirror forms. So pretend that this mirror, if you want to pretend it's like a circle and you want to draw it all the way around, if I was making a big circle, the center of my circle is my C. So that's where that comes from. Now, the F is the point which the parallel rays converge or appear to converge. So if your F is here, that's what I mean, they are converging. If your F is back here, it appears to converge. It doesn't really. So we have our R is going to be the radius. So it's going to be the point from your center of curvature all the way to the mirror itself. P is going to be your principal axis. And then we have V. This is your actual center of the mirror itself where the principal axis lands. So this is your mirror. That is the center of the mirror right there. So that's different than the actual center of the whole circle. So we're going to use those points to make some determinations. Are y'all with me so far? Okay. Y'all can still stop me and ask questions. So the first mirror that we're going to look at is it concave or convex? Yep, concave. And for concave mirrors, does it converge our light or does it diverge our light? Converge, correct. And a mirror B, is it concave or convex? And does it diverge or converge? Diverging, yes. Diverging. Okay, so what happens here is that your light is going to hit the mirror, and then when it bends, the light should all pass through your focal point. But over on this side, it's going to diverge away. So if you were to think about your light ray hitting the mirror and then bouncing off, it's almost like that second bounce off. That's the line that's going to pretend to go through the focus. So anything to the right-hand side, I do dash lines because those are not real images. Those are virtual images. So if it's actually reflecting off, that's going to be your real ray, your light ray. Light can't get back here. Remember, it's opaque surface. Okay, now grab a ruler, and we are going to practice drawing our rays and trying to decide what our image is going to look like based on where the object is placed. Okay, so remember down here, this first arrow that you see that we give you, this is the object. Okay, and so we're going to start out with a concave mirror, and then we're going to do a convex mirror second. So the first rule when you're constructing a ray diagram, it says the incident ray parallel to the principal axis, first, that's the light ray that's parallel to the principal axis, will go through, when it's reflected, will go through the focal point. The focal point. Okay, let's go ahead and draw what that means, what that looks like. I'm going to color that pink. So the first line will be pink. So down here on my object, and honestly, there's a lot of human error when you are drawing these ray diagrams, so do not panic if your object is not reflected the same way mine is. You're going to get the hang of it, and you're going to know after you do a few what it should be doing based on where the object is located. But for now, just bear with me and don't panic if you don't crisscross right where I crisscross. But it says, first line is parallel and then reflects through the focal. So at first, parallel. Now I'm going to reflect through the focus. That's my line number 1. I'm going to color it pink. So line 1, I'm just doing what it told me. Incident ray is parallel to the principal axis and then reflects through the focus, right? Parallel and then reflects through the focus. Okay, line 2. This is where your incident ray, your incoming ray, it goes through the focal point and then reflects parallel to the principal axis. I wish I knew if my speaker was like over here or over here. I'm not sure where it's recording me, but anyway. Okay, so I'm going to make this line orange. So first I have to go through the focal. That's my first step, and then I have to come back parallel. So I'm going to go through the focus, and then I'm going to come back and go parallel. Eyeballing it, I feel like I'm doing a good job being parallel to the principal, but in reality, there's still human error. This isn't perfect. I think a computer program would make this look a lot better, so I apologize if it's not beautiful. But I'm going through the focus, and I'm coming back parallel. Okay, so that was my line 2. Okay, do y'all see how I'm following the instructions? Just step by step. These are just the rules of drawing ray diagrams. Okay, third, my last line. The ray will go along the secondary axis through the center of curvature, and it's reflected back along the incident path. So basically, goes to the curvature and comes right back the way it came. That's what incident means. Goes in and then goes back out the exact same way. So reflected back along the incident path. Because the angle of incidence is 0 through the curvature. So all that means is I'm basically just going from the same spot that I started from and if it were to reflect off a mirror, it would be just bouncing back the way it came if it actually made it down to the mirror that far. Okay, so that's really your line 3. In a perfect world, all 3 of those would have crisscrossed. See, I cheated a little bit. I just started a little bit higher there because I was trying to make my way over there, but you'll get used to it and you'll kind of know when it's supposed to actually crisscross. Especially your first 2 lines. Line C, you can get away with this without doing line C. Okay, so your first 2, that's pretty much kind of what you want to go to. Now, where is my image? Your image is where all 3 crisscross, and that first line that you draw is always the tip of your arrow. So that's why my arrow is actually like that. Okay, so what kind of image is this? Is it real or virtual? Virtual. My image, is it on this side of the mirror, or is it over here in La La Land side? It's real. Is it upright or inverted? Inverted. Look, it's upside down. Look at my arrow top here and my arrow top here. It's upside down. Tip of my arrow. If it's on the other side of your plane, if it's back here, then it's going to be a virtual image. But the image bounces back and it lands here. It would be upright. Upright. Okay, so is it enlarged or reduced? Bigger or smaller than the actual? Is the image bigger or smaller than the object? Yes, smaller. So we're going to call that reduced. Okay, so this is my object, this is my image. And okay, so that's for concave mirror. Concave mirror are going to have different scenarios based on where your original object is located. Now, the next one we're going to do is a convex mirror. Convex mirrors always are going to have a virtual image, okay? Always are going to be virtual. And because the image is always going to be located on the opposite side of where the object is. And we know in real life, we know light can't get there. This is an opaque substance, which means it's going to reflect your light rays, okay? So we're going to treat it the same 3 rules apply. They're only a little bit different because as soon as the incident ray hits the mirror, it reflects. So the same 3 rules, so we're going to go step by step with them. Okay, so for the first one, it said incident rays, the pink line, incident rays parallel to the principal are reflected to the focal point. Okay, so I'm going to go parallel and then through the focal point. I'm going parallel until I hit the mirror, and then I'm going to draw the line toward the focal, but there aren't real rays over here. So I'm going to display that by doing a dashed line instead. So if I'm on the virtual side of La La Land, I'm going to do a dashed line. Okay, but what really happened to that light ray when it hit the mirror? It reflected, exactly. Now, the direction that you draw that reflection was toward, it was away from the focus. Okay, so that's my line 1. I did the same thing I told you in the rules. So the incident ray was parallel to the principal axis and then reflected through the focus, the focal point. So that's my line 1. It goes in and then back out. But dash, 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 dash. The second one's a little trickier, okay? Because it says the ray goes through the focal point and then it's parallel. Okay, so it goes through the focal point, then parallel. So I'm going to draw my line toward the focal point. And you're going to be tempted, see I have to stop at the mirror. Stop at the mirror because I have reflection. You're going to be tempted to want to carry on your imaginary line toward the focal point. Do not do that because you're going toward the focal point and then you've got to go parallel to the principal axis because you're reflecting off. That light ray has to reflect. So what did my rule 2 say? The ray goes through the focal and then reflected parallel. So I followed the same instruction. Exactly. So you pretend you're going to go through and then you do parallel. But where are my imaginary lines going to go? So my imaginary line, basically, if you think about it, going off that bent reflection. See, on that first example, I went parallel and then toward the focus. So see how it's that second line where I drew my imaginary lines. On this one, same thing. I went toward the focus and then parallel. It's that second line where I'm drawing my imaginary lines. And then the third one, I'm just pretty easy because it's always going to go back out the exact way it came in. I'm going toward my C. So I'm going to basically go boom and then right back out again. Boom. Then I could take my dashed lines toward the C. And then I'm looking for the area where all 3 of them crisscross at the same time. And you start out with your first arrow. So that's where all 3 of them crisscross at the same time. Let me draw in my yellow lines. Okay, I'm going to go back and finish my color coding because my first line was parallel and then through the focus. My second line was through the focus and then, or there I am, through the focus and parallel, and that's orange. I need my orange color. My second line was toward the focus and then parallel. And my third line was toward the center of curvature. I'm going to be really upset if this is too hard to hear. Okay? Okay, oh poopers. Okay, so the properties for this one, is it virtual or real? Virtual. Virtual. Is it inverted or upright?
Upright.
Is it reduced or enlarged?
Reduced.
Okay, now flip the page and let's practice some together. Okay, now we're going to practice some in-class practice together. And you'll notice that on these, your object is going to be placed in different locations. So we're going to do 5 different practices with your concave mirror before we do one more convex mirror at the bottom right-hand corner. So let's do the top left together. And by the way, this is where I want to tell you that your lines may not crisscross exactly where mine crisscross. Do your best and don't have a panic attack trying to be perfect. It'll be okay. Okay, so the first one, we're going to follow our rules. Rule 1 said parallel, then through the focus.
Wait, Miss Edel.
Yes,
For
ma'am.
this test, are we going to have to memorize the rules?
Okay, so then we go down through the focus. Yay! And I'm even going to give you that color-coded line. Andrew, how are you doing on yours back there? All right, what is my second rule? What do I do next?
It goes through the focal point.
Down through the focus, then parallel.
And then what? Go to C. Shut up.
And then what's my third line? Straight through the C, and incident ray would bounce right back again. So it's going to go down and back. It goes down, and then it bounces right back. Back out again. You always start the tip of the arrow of the object.
I'm talking about to draw the image.
Yes, you start from like that very, very first line that you drew. That pink line was the tip of the arrow.
Okay.
The very first line is the tip of the arrow there, so it's going to be the tip of the arrow. I know, I have one more convex down at the bottom. Okay, so what is going on with this image?
It's real.
Real, yes. What else?
Inverted.
Inverted, upside down. And? Good job. Okay, that's what happens when your object is this far is beyond the center of curvature. When your object is beyond the center of curvature, your image is going to be real, inverted, and smaller. Okay? Well, what happens if your object is directly on the center of curvature? Ooh. Ah. Hey, guys, can you do line 3 for this one?
No.
Nope. But I can go parallel.
Wait, why not?
And down, because you can't go through itself, because it's like starts here, can't go down. It's not reflecting back from anything. If you did, it basically just goes straight down. But anyway, so that's line 1. Line 2, what does line 2 do? Yep, line 2 down to the focal point. Exceeded. Because I know what this is going to look like, and I want to make sure my line's pretty. Okay, so yes, I go down through the focal point first.
You see that I'm recording?
Yeah.
Uh-huh.
Because I'm telling you, there's like a little bit of human error when you're drawing these lines. It's not going to be absolutely perfect. And so I'm trying to make this one look a little bit prettier. Be bouncing back. If I had a really thick pen, that would be even lovelier. Anywho, so you start from the top, you go through the focus, and you go back and bend. but I know my rules, and I know that my image is supposed to be right here. Because if your object is on the center of curvature, you have an identical image that's the same size, but upside down.
So it's real.
That's just one of the properties. So yes, it's real, it's inverted, and it's the same size. Ah! So sometimes I fight with my lines to make them just right because I know what it's supposed to look like. Like I know this one's supposed to be smaller. I know this one's supposed to be the same size. I know what's going to happen to this one already. And you will too. By the time you practice some of these, you know your properties of where your object begins and where. Okay? So yeah, my second line was right here. Forgot to do that. Okay. Let's do what happens if your object is in between the C and the F. I'm going to have to fast forward this when I actually poopers. Then it goes down through the foci. No, my battery's about to die. I don't like this ruler. It's got little ridges in it.
There's not cookie.
If I wanted to, I could do a C like that. Because I know what it's supposed to look like, so I'm like very careful. I'm very purposeful with my lines. Okay, so my line 1 was pink. Once y'all have this note sheet that you're doing right now as a guide, you'll kind of gauge better. Okay, I know my object's supposed to end up, my image is supposed to end up over here. You do your pink line first. Hey, that's what I did over there. You don't see me kind of start with the other way? That's what I mean I cheated. I started with the other way. So what is up with this one? Real or imaginary? A virtual, why did I say that? Real. Is it inverted or upright? And enlarged, yep. So generally speaking, you should know now that when your object is in between C and F, it should end up being, your image will be out here and it will be larger. Okay? Ooh, another unique scenario. Scenario number 4. What happens if your object is on the focal point? We actually talked about this yesterday in your notes. Well, what happens, I can do my first line, but I can't do my second line. I can't go through the focus because I'm on the focus, right? So I can do my first line. And I can't do my second line, but I can do my third line. Now, if I had drawn this beautifully, exactly, it kind of is, but I feel like it should never touch. It should be parallel forever. And if I had done this like with the real computer software or whatever, I'd make that look a lot better. But yeah, so those go on. So is there an image?
No.
No image. Blind spot at infinity. So your light's just simply reflected and you're not going to see it. Oopsie, I didn't even bounce this off the mirror, did I? So basically, if the light was coming, it could hit the mirror and then just come right back again, but it would never touch. Okay, so those lines would never touch. Now what happens though if your image is in front of the focus? Okay, let's see. I can do my, I can go parallel through the focus, right? That's line 1, that's my pink line. Parallel them through the focus. Be forewarned, this one's a little funky, kind of like your convex mirror. You already figured it out, didn't you? So this is going to hit the mirror. And then come back through the foci, because that was my first line. Can I do the line where I go through the focus and then parallel? Nope. But can I do my C just like I did up there? Yes. So I can hit my mirror and then come back and go through my. So what happens here, that my pink line, that was my first line. This was my third line. Oh, poopy. Leave us alone. We gotta do this before it dies. My plug's too far. Those go back like that. Where they crisscross and meet. Oh! We have ourselves, squad, a virtual, upright, enlarged image. Cool, huh? That's our image back here. So, is there really light back here? No. It appears that there is, and it appears that our object is larger than it really is. Our object is right here, but its reflection makes it look ginormous. Okay, let's do our last example. And notice this is another convex mirror. This is a little tricky the first time using a different pen. So let's just go ahead and do rule 1 and 3. Let's do steps 1 and 3 and skip 2 for now. We can go back and do 2, but just for simplicity's sake. Remember, rule 1 is parallel, then toward the focus. Parallel. And then I'll draw my line toward the focus, but it reflects. I can't really draw it toward the focus. It's actually reflecting out. But my okay, and then my third line is through the center of curvature. Remember, if I go on this side of the plane, it's my virtual side, because light doesn't really get backward. Try to keep it dashed on this side, because it's actually going to reflect straight back out with your third line. There's like angle of incidence comes, your ray of incidence goes back out to the ray of incidence. Okay, so we did not do second line. We did the first line, which was parallel, then where the focus would be. And then the third line was through the C. And we'll bounce it right back down. But, okay, so our image should be right about here. Now, just for fun, let's do that second line. It's the tricky one. And see if we can get it right. Our second line, we said, goes toward the focus and then parallel. So this one's going, where's our focus? Down here. This one's going toward the focus, and then it would have to bounce off and go parallel, deflect that. And so it would be the tail end of that one that we drew. And if my line wasn't, it's actually really parallel. That's not parallel. If that is actually parallel. Okay, so that's my orange. The second line would have gone toward the focus, but we can't. We can't cross through it. It's being bounced back out. So what's happening with this image? It is virtual. upright.